Hello everybody and welcome to today's webinar. This is our final webinar in our Sprint Ask the Author webinar series, where we've been exploring some of our Sprint findings. So Sprint is a large EU-funded project that has been running for 5 years now. We're coming towards the end of our project with a big final conference in Brussels on the 25th of June. And we've been looking at the integrated impacts of pesticides on both the environment and human health. So today's webinar is focusing more on the human health side of things. So we're looking at indoor house dust in agricultural settings. I'm very pleased to say that we have 2 speakers today. Both are Sprint partners. So we have Paul Scheepers, who is an associate professor at Radboud, and he's our chief science coordinator. Paul will be presenting our Sprint related findings around indoor house dust, whereas Daniel Figueiredo, who is also a Sprint partner based at Utrecht University, will be presenting some of his wider research around indoor house dust. So this work isn't directly from Sprint, but it's heavily related and of interest to us. So welcome everyone. Please do post in the chat if you have any questions. There is a separate Q&A function which we'd prefer you to use for questions, but don't worry, we can move them across either way, whatever's easiest for all of you. Please do also introduce yourselves in the chat. We'd love to know who we have here today. Just to say, the webinar is being recorded. We're going to post it on our YouTube channels afterwards. None of our participants are on camera, so hopefully that's all okay. We will also be making sure to post useful resources and links throughout the session, including to our speakers' papers and other resources such as our blog posts. If there are any additional resources you'd like to hear about, please again let us know. And yes, so without further ado, we're going to pass over to our first speaker. So we have Paul Scheepers. Again, he's our Chief Science Coordinator for Sprint. Paul is going to provide an overview of 2 of his recent published papers, both of which explore pesticide residues in indoor house dust across Europe and also in Argentina.
Thank you very much, Charlotte, for the introduction. So I'm pleased to meet you all online to talk about 2 of the papers that resulted from the Sprint project. The first authors of both papers were not available today to present their work, but I've been in touch with them for preparing this slide deck. So and before going into the content of the research, I would like to just briefly show the content, what I'm going to present the next 15 minutes. So I will present very briefly the overall objectives of the project and the activities, and then I would like to discuss the study characteristics, the results, and go through all the results with you. Some results have been taken directly from the papers that you will also find online in the publication page of the Sprint project. And then I will go through some points of discussion and also interpretation of the results and the meaning of the results. And I will finalize with some take-home messages. So let's get started with the overall objectives of Sprint. And maybe it's good to know that we would like to support regulators and scientists to improve on their on the overall assessment of risk to human health and an environmental impact of the use of pesticides. Also including including the farm animals and wildlife in the neighborhood of farms and fields of applications of pesticides. Maybe good to know that we have worked together with farmers and stakeholders to learn about how to maintain production of crops in the interest of food, of let's say good quality food, but with of course being mindful of the impact of the use of pesticides, and let's say trying to find out about possible ways to reduce the use of pesticides. So for that we have done a study in 10 countries in Europe. I'm not going to detail, but maybe it's good to just mention that of course it's tempting to compare the results by country, but actually it's maybe more interesting to compare by different crops that we have studied in each of these countries. And also the focus that we had on comparison between what we called integrated pest management, that we just labeled conventional use of pesticides, and the alternative of biological farming. On the right side of the slide, you see all the types of materials that we have been collecting in the growth season of 2021. The topic of today is to look at indoor dust. So that's only, I think, one of the, I think it's right here. It's indicated by the symbol of a broom, where we looked at indoor contaminants in dust. So I hope that you had the opportunity to also join other sessions of, let's say, the stakeholder meetings, or maybe the other sessions discussing the results of this project. I would like to, because we are going to look at two research papers, I would like to present the results, well, the study design, but also results in a kind of structured way, and also show that actually these are very different types of studies. I would like to, before we're going to look at the results themselves, I would like to make clear in what in which aspects they are comparable, but also I think in many aspects they cannot be compared. But I hope that they will show you some interesting perspectives on how we can find pesticides in our homes. So the overall aim was in line with the Sprint project for the study done by Navarro and co-workers to study the households of farmhouses of conventional and organic farming in the 10 EU countries and also in Argentina. And then for the study that was carried out in Argentina, it's maybe good to know that this was done in a particular region of Argentina, very close to Buenos Aires. For the methods of sample collection, it's good to know that the Sprint protocol used vacuum cleaning, and the additional study in Argentina adopted the sweeping of floors as a method of sample collection. These are small studies. The EU study was based on 128 farm homes and additional 40 homes from Denmark and France related to neighbors and consumers. And in the Argentina, the study was carried out in homes of consumers. So both studies were relate to the growth season of 2021. And I will show you some of the home characteristics and let's say activity patterns of the participants in the next slide. But maybe good to know that we compared 65 households of conventional farmers with 63 households of organic farms. And in the Argentinian study, 22 neighbor homes were studied and 26 so-called consumer homes. So the neighbor homes, the labeled neighbors is used to indicate that these homes were in a rural area. We used the characteristic neighbor to indicate that they were close to fields of application. So both studies used LC-MSMS for identification and quantification of the pesticide residues in indoor dust. And the Navarro study looked at almost 200 pesticides, including one synergist, and the study that was carried out by Apparatio was addressed the pesticide, not 49 pesticides. So let's now have a look at how these homeowners or household members used pesticides that at home, let's say, in addition to what was maybe the result of introduction of pesticides from outside the home. So here you can just see by responses, self-reported, let's say, percentages, the activities. So you can see that actually the overall use of pesticides in homes was much higher in Argentina compared to the 10 countries in Europe, and included pet-related use of pesticides such as preventive treatment against flea or ticks, other veterinary use products were used, and also other uses of pesticides in the homes. And also in Argentina, maybe good to know that almost 20% was of the household members actually had an occupational connection to pesticide use. So the most interesting finding that I will go into later in my presentation is that the finding rate, the rate of detection was quite high. So in the Navarro study, you can read that almost all the target, let's say, substances were actually detected. And also the detection rate in the much smaller study in Argentina was also quite high. This resulted in a number of detected pesticides between 25 and 141, with a median of 80 in conventional farming and 65 in organic farming. So interesting difference here. And then in the other study, it was a range between 19 and 32 pesticides per home, or per sample, I should say. Very good to know that in these homes, a considerable number was is actually related to pesticides that do not have a current approval. So that's quite interesting and indicating that pesticides are still around, although some of them have been banned for several years or sometimes several decades. And then I will give you some numbers here, but I think it's good to maybe move on to a presentation of the results. And then I would like to start with the study that tried to describe the pesticide residues in indoor dust by functional group, and that's the picture on the left. Then you see that in both conventional and organic homes, the most by far the most detected were insecticides, and maybe I should make you aware of the units on the y-axis, which are on a 10 log scale. And concentration here is in ppb, nanogram per gram. And you can also see here that there's a very wide distribution in terms of concentration, and that there's a tendency that organic farms may have, or organic households may have somewhat lower values. But because of the very wide variability, this was not a statistical significant finding. And on the right, you see by each of the 11 locations, the difference between the conventional farm households and the non-conventional ones. Maybe interesting to show that in countries like Denmark, there seems to be a very small difference, but in other countries there's a substantial difference. Also maybe related to the specific region and the specific crops that were grown in on those locations. Now moving to the kind of busy picture showing the results by substance. Again, I would like to make you aware of on the Y that we are looking at 10 log scale, and then maybe to guide you a little bit, where you see the number 3, that actually is the level also indicated as ppm. And then the level 0 is actually the level that we sometimes refer to as ppb, so 1 parts per billion. So actually what you can see is that although we have detected very many compounds, that for most compounds, as you can see here, the level was very much lower than ppm level. And on the other side, let's say, and that's of course also interesting, that there also were some chemicals with median, or at least let's say in the high range concentrations above the ppm level. I will explain more about how to look at these concentration data. Then you can also see what is maybe typical for many findings in the Sprint project. That's a very wide variability that I think that maybe Daniel can later show, that of course you can do a lot of analyses to find out about how these concentration values may be attributed to some characteristics in homes. I will not say too much about that in this presentation. But I would like to just share some thoughts also for discussion. First, I think it's very important to point out that there is a difference in method of sample collection, and it was a lot of discussed, I think, in the peer review, let's say, of the manuscripts, and to what extent vacuum cleaning is maybe overestimating, let's say, the dust that we have direct contact with, and sweeping is maybe also a method that's maybe not so well standardized, but both methods have been reported before in dust studies at homes. Then I think that it's very difficult to say to explain the source of pesticides, but I think that looking at this study and the study characteristics, and also looking at the wider collection of studies that looked at indoor dust pesticide residues, we can just say that there is many different sources. Some sources are related to the build of the homes, like wood conservation. Some are related to the specific use of pesticides in their homes, like insect repellents and veterinary use. And there is also, of course, the products that we introduce ourselves as residents, thinking about fruits and vegetables, flowers, maybe also ornamental plants that have been treated with pesticides. Maybe also tracking. I mention here shoes, but actually overall clothes that carry maybe some residues. And also, let's not forget that if we walk our dog or let our cat go outside, the pets may also collect some residues outdoor, like by feet or fur. And then I already explained to you that we also like to keep some insects away from our pets, like fleas or ticks. And that also involves the biocides that have been authorized for that use. Last but not least, I think we expect at least some penetration of gas, liquid, and particle phase from nearby pesticide applications. So that's when I refer to the neighbors, I'm referring to potential residues from nearby use of pesticide applications, like spray drift that may play a role, or also evaporation from vegetation. And then the big question is, and this also for discussion, is why do we find so many residues of maybe also pesticides that we normally know are degraded when used outdoor on crops? We think, and there's also, let's say, some papers where authors also suggest that this may be related to the type of environment where outdoor with sunlight and specifically the UV part of sunlight may cause degradation of pesticides on surfaces of crops. And also moist conditions could lead to hydrolysis of some of the chemicals. All these factors may be less of interest in an indoor environment, which tends to be much drier and maybe devoid of any UV light. I'm quite sure that Daniel will later show that there's indications that also activities like cleaning homes will actually also indicate that pesticide in homes are lower, and I think that the sprint results from the wristband study also indicate that. Let's now move to interpretation, and I've tried just to add to the paper. This is not part of the published paper, but I tried to make some deterministic calculations to try to understand how the dust levels can be interpreted in terms of uptake compared to the framework of safety of food, and then I refer to the acceptable daily intake that is given here for 3 pesticides that have been highlighted in the Sprint project for research because of the very wide occurrence and also because of some concerns related to the toxicity. Here you see, just based on the results of the Navarro paper, that I've done some calculations to convert the pesticides found in homes to values that can be compared with the ADI, and I do that for 2 potential routes of exposure. That's first hand-to-mouth contact, and the second is inhalation. And I, in both cases, have looked at a scenario for an adult, and I looked at a scenario for a 1-year-old child. And the main difference is, of course, the size of the body and also the weight of the body, where I think also that's also part of the definition of the ADI. Maybe good to know that ADI is defined as the level that we consider to be safe for the average person, but also ADI is supposed to include all the susceptible individuals in a population. Not for one day, but actually for every day of a entire lifetime. And here you can see the result that I would like to highlight. I don't remember. Yeah, actually, I should have highlighted for adults. Here I give the results. Maybe that's maybe easy for you to understand. That's the percentage of the ADI that is can be explained by this type of uptake, hand-to-mouth contact. Based on uptake of 100 milligram per day, which is actually, I think, a very conservative assumption. So here you see that actually the size of the body and the age of the person matters, because you can see that the levels calculated for children are much higher, but still well below, let's say, 1% of the ADI. And then I would like to go to the next slide. I will not explain in detail because it's exactly the same scenarios, but now for inhalation. And then I also show the ADI as a percentage, the uptake by inhalation as a percentage of ADI. And you can see that actually inhalation explains a very low contribution. Under the assumption that for indoor air, we have just assumed that the dust that becomes airborne results in a concentration of around 0.1 milligram, 100 micrograms per cube. And here again, you see that if you compare the contribution for adults and children, that for children it's much higher. And also I should mention that inhalation, the tidal volume, let's say, of inhalation is a bit higher in children. So let's now go to the last part of my presentation, which is actually showing the take homes. The take home is, of course, the high number of substances, where we need to, let's say, remember that actually we don't have a system to we don't have a good method, reliable method to assess the mixture risk. I should also mention that there is a difference between organic farm households and conventional farm households. Concentrations of insecticides are comparatively the higher than those of herbicides and fungicides. And I also showed you some calculations to try to understand the contribution of both hand-to-mouth and inhalation uptake. Last but not least, I understand that, and I think that it's understandable that you don't want to have these substances in a home. So what can you do to limit the pesticide residues in homes overall? Think often, of course, you have options to choose for organic products as an alternative to products that may contain chemicals. Maybe it's good to know that especially flowers and ornamental plants don't have any regulations at the moment, but maybe in the future that will change. But for the moment, I would say, you could consider organic alternatives if they are available. And then very important, I think we have many indications that especially the use of some biocides that are used to keep away fleas and ticks from our pets, that type of use can be is associated. I think that Daniel will also show some results with the occurrence of those particular active ingredients in those products. last but not least, maybe that's reassuring that the cleaning, self-reported cleaning, was also associated with somewhat lower occurrence of pesticide residues in homes. And this brings me to the last slide, where I would like to thank, of course, all the people involved in doing this research, specifically the lead authors of both of the papers. And I'm happy to take any questions. Thank you.
Brilliant. Thank you so much, Paul. A really interesting talk as always. And I do now feel a bit shamed into cleaning my house a little more. So it's great. It's great that you have some recommendations, though, particularly because there are no regrets and there are things we can all do to avoid exposure in indoor dust. So we're going to hold our question and answer session at the end of the webinar. So please do keep your questions coming. We have noted them all. Some really interesting questions coming up already, so that's brilliant. So without further ado, I'm going to hand over to Dr. Daniel Figueiredo from Utrecht University. As I said when we started the webinar, he is a Sprint partner. However, today he is going to present some of his wider research around indoor dust. So away you go, Daniel, and looking forward to hearing more about your research.
Yes, thank you very much, Charlotte. I hope you can see my screen. One of the papers I'm going to talk about today was a paper that we published in 2022, part of a Dutch study called OBO. This was a part 1, where we focused on pesticides close to treated fields and mainly flower bulbs. And ongoing at the moment, we have part 2, where we focus on orchards. So in short, what we did in this study is close to flower bulb cultivations. We looked at ohms within different distances from 1 meter to 250 meters. Let's call this location ohms. 6 of these ohms, farmers lived on them. And we also had ohms more than 500 meters away, we called controls. In these ohms, we collected vacuum floor dust, same method as explained by Paul. And we also had doormat dust. These were doormats that we placed before a spraying event. They were there for 1 week, and then we collected them. We analyzed 46 pesticides. I'm not going to tell into all of them. The total was 11 herbicides, 12 insecticides, and 23 fungicides, reported to be applied in flower bulb cultivations. And we also had questionnaire data, number of pets in the houses, which types of pesticide they use, ventilation system, and so on. We did this both in the use period. Use period is basically the period of the spraying season, pesticides are being applied, and the non-use period, usually end of the year towards October to December, where there is no pesticide application. There were 5 aims defined, and I'm going to focus on 4. Study the patterns of occurrence, study temporal differences between the spraying season and the non-spraying season, study spatial differences. As you know, we have different distances from the fields, so we study the spatial difference. And finally, try to understand which determinants or factors explain the occurrence and concentrations of pesticides. Let's first look at occurrence. And this might be a complex table, but I'll take you through the table. In the first column, you have several pesticides. These are pesticides reported as being applied in the bulb fields during the study period. The second column, you have the far ohms. So these are the 6 ohms that I mentioned where farmers live. You have divided by the use period and the non-use period, and then by VFD, vacuum floor dust, and DDM, dust doormat. So this is just the occurrence, 100% meaning we found it in all samples. And of course, you can see that it varies quite a lot between the pesticides. What we saw is that several fungicides were mainly persistent, mainly found in these samples. And when we move to the log ohms, these are ohms where farmers do not live but are located within 250 meters, we still see occurrence, although it starts decreasing. We still see quite prevalence of fungicides. And when you move to the controls, the ones more than 500 meters away, occurrence is even less. And I'm just talking about occurrence, not concentrations, basically detection or non-detection of a pesticide. Interestingly, we also had a group of pesticides, which I'm now showing in the bottom, that were not applied, but were reported as used for bulb disinfection. for this group specifically, we saw that there was presence in both use and non-use period, but also quite some presence in location-omes and controls, adding to the importance of understanding what are the sources of the different pesticides. Now we move to temporal differences. I'm now just showing one pesticide as an example, because it might be a complex plot. In the y-axis, you have concentration in nanograms per gram. In the x-axis, you have U for use period and for non-use period, and the C is controls. What you see here in this example is that we had concentration significantly higher in the use period for locomes versus controls, and the same for the non-use period. Even when pesticides were not being applied, almost closer to fields at concentrations of boscalid, which is a fungicide, higher in dust than controls. Now, this is a bigger picture for different pesticides which we frequently detected. Overall, we see the same pattern. Concentrations higher in the use period than the non-use period, which we expected, and concentrations higher closer to fields than further away, which are the controls. And this also brings to this distance pattern. I want to highlight just this table, not looking now at the images. The trend that we see is that for both the dust doormat and the vacuum dust, there was a significant decrease in concentrations for 5 of the pesticides. For one of them, actually, we found an increase in concentrations when you move further away. And then for 6 cases, there was null, meaning there was no significant differences between different distances, likely a matter of persistence, but we'll come to that. Now, what are the determinants? This is quite important to just keep a bit looking at this table. I just put the variables first that we looked onto. We build a model with the different information that we gather from questionnaires. And then we did a selection on the different variables. In this case, it was a backward selection. And the variables that came out that were determinants of occurrence was the vapor pressure relating to the pesticide, the DT50, the kilograms of the pesticide applied, the distance to the field, and the dust spread. Now, it's important to inform here that this dust spread is a modeled value, which we modeled as how much we think it would be in dust-based concentration in air, and this is just based on partition coefficients. So we had the concentrations also measured in air, and we tried to predict dust. If we look at now the results, what you see here is the following. Let's focus first on the dust doormat, DDM. This odds ratio indicates if it's above 1, there is an increase in occurrence. What you see here is, for example, if you look at the environmental DT50, the degradation half-life, that there is a 90% increase in occurrence for a 10-fold increase in the environmental DT50. We see that this was the true for the vapor pressure. This was true if more kilograms were applied. This was true for the concentrations in air. However, for distance, this was inverse. It was below 1, meaning the further we were away from the fields, the lower was the occurrence of a given pesticide. For the vacuum floor dust, we saw exactly the same parameters appearing, both explaining occurrence and concentrations. However, distance was no longer appearing. And this is key, because the vacuum floor dust is an accumulation through time. Because when we sample it, it might have accumulated for weeks, might have accumulated for months, while the DDM, dust doormat, as I mentioned in the beginning, we put it for 1 week, it was a clean doormat. We are just capturing that week period. And we clearly see this in the modeled results, where distance do play a part in that, but when you look at vacuum floor dust, which is accumulation, it actually accumulates over different distances, and then we don't see that trend anymore. So from this research, my take-home messages are that they were found in indoor dust of all homes included in our study. Pesticides people living close to fields were exposed year-round, both in the use and non-use period. Indoor exposure was higher closer to fields. Concentrations in floor and doormat were moderately to strongly correlated, and I want to stress I did not show this in this presentation, but I recommend reading the article. And we were able to accurately predict occurrence of a given pesticide in dust. 75% of cases, we actually predicted that a pesticide would occur, and indeed we measured above the limit of quantification. For those that are thinking using also dust as a matrix for sampling pesticides, there's some recommendation here. What we saw is that the dust from the doormats can capture an exposure in clearly defined time frame, while the vacuum floor dust actually captures both past and current exposures. Might be more appropriate for health assessment, but not to actually capture just specific time windows. Now, I did not want to just focus on my study because the research needs to be a collective effort. And I want to just focus on two more studies really quick before we go into the questions. And one is this human exposure to pesticides in dust from 2 agricultural fields in South Africa. And I want to grab a piece from that paper and stress one very important thing. And I'm going to read to you, which is many studies have assumed that all pesticides present in dust were bioaccessible. Bioaccessibility means that when they enter the system, they can be uptaken by the system, by our body, basically, when they enter our body. Because we did not have, and we still don't have much information on this bioaccessibility. For what they saw in this review is that on average, the median of bioaccessibility for legacy and current pesticides is 0.14, meaning only 14% of the pesticide can be released from the dust and absorbed by the body. And this is really important. Another important thing is the importance of having multiple studies. As Paul indicated in the end of presentation, in the sprint study, we did not see any risk, at least when compared with acceptable daily intake. What I want to show you now is a report which I was part of the methodological development, and we are now putting out a peer review publication on this called the SOS Labkamer, done in Belgium and the Netherlands, where actually we see in one of the ohms for fipronil, pesticide no longer authorized for agricultural use, but can be used as a biocide. We saw this max concentration of 20.1 milligrams of fipronil per 1 kilogram of dust. If I translate to milligram fipronil per milligram of dust becomes 0.000201. If I now take an example that also Paul used, in this case, a 1-year-old 9 kilograms ingesting 100 milligrams of dust, that results in an exposure of 0.0022 milligram fipronil, which interestingly, just from dust, this is higher than the acceptable daily intake for fipronil. Why am I showing this? Is because I want to stress that just because one or other studies do not find a risk, that doesn't mean that there is no risk. It needs to be from different studies, different comparisons, different environments that we can draw a conclusion. And this is actually the message I want to bring this, drawing conclusions from several studies and not just one. I also want to stress that in obo, from dust, we also did not find any risk. Finally, the last message is the complexity of the dust matrix. First, house dust is very heterogeneous. It's a mixture of particles, hair, fibers, biologically derived materials such as molds, animal fur, ash, among other components, which makes it already very difficult to analyze and to understand what are the different sources. Moreover, there are a lot of ongoing adsorption and desorption kinetics that also differ depending on particle size fractions. And if you're interested, I invite you to read the research by Koskola, where she noticed that some pesticides bound to actually smaller particles than other pesticides, which for some reason have affinity to larger fine to coarse fractions. And the last but not least is that there's very different processes and factors that influence accumulation and influence the degradation. And these are just a list of examples such as wind erosion and take-home route mentioned also by Paul, deposition, accumulation, and resuspension, such as the size of particles, but also disturbance of surfaces, vacuum cleaning frequency, which is also seen in obo, type of flooring, carpet versus vinyl flooring, for example, and the degradation of pesticides in the indoor environment, which is also a subject that needs careful research, and more research needs to be done because you also have, for example, a lot of shaded areas which do not have photodegradation, so the pesticide will persist for longer. Another thing is that from several studies, the dust half-life, so just of the dust matrix itself, can go from 7 months to 10 years. I mean, it can happen that in certain homes, a dust is just somewhere in a corner for many years without being cleaned. And if that resuspends and moves around the home, it can easily actually have banned pesticides because it was there for a long time without being degraded. And that was all. Thank you so much. And I'm happy to answer any questions.
Brilliant. Thank you so much, Daniel. Again, a really interesting talk, and I can see we have lots of questions that have been posted. So what we're going to do is work our way through them. Some of the questions are directed at one of you individually. Others, it might be that you could both have a go at answering. So that'd be great. So first of all, we have a question for Paul from Doriette Williman. So I say, thanks for your presentation. Did the sprint team also make a comparison between households at a farm and in neighbour households as well?
Yes, good question. Maybe you've seen that actually in the study that we performed into 10 countries that was standardized, we have had a focus on farm households, and there were 2 countries, I think, if I remember well, Denmark and France, where we also looked at consumer homes and neighbor homes. So, but actually, we did not really wanted to compare the results of the standardized study with the results of those 2 countries. So that was, but it's a good question, I think, and yeah, I would like, of course, also to know to what extent we can expect maybe some of the pesticides to be related to the use in farming that are maybe not found in private homes far away from the fields.
Brilliant, perfect. Next we have a question from Helmer, and I think this could be aimed at both of you actually. So the question is, the intake by inhalation depends strongly on outdoor air concentrations. What concentrations did you use for that concentration?
Maybe Daniel, you want to take this question?
Yes. Well, I'm not sure if it's yet publicly available, the deliverables, but we did use outdoor air concentrations using active air samplers in 2 locations, and we used the measured air concentrations to calculate inhalation. And we also applied uncertainty in those calculations based on measured air concentrations from other studies.
Brilliant.
Perfect. Yeah, maybe I can add that for the calculation I showed, I just assumed that the indoor dust would become, let's say, resuspended or would become airborne, and then I just assumed that that this would be 0.1 milligram per cubic meter. So that was my approach.
Brilliant. So we have a question from Carla Cohen for Paul, but again, I think this could also be relevant for Daniel. And I'm aware that Sprint has focused a lot on cocktails of pesticides, or well, mixtures. We try not to use the term cocktail too much. But Carla has asked, so Paul, does your research account for cocktail intake?
Yeah, we are very much interested in that, and we are following up studies to assess mixed exposures, but have not, let's say, done any work related to the indoor dust, related to cocktails.
Perfect. And another question from a different Carla, actually. So Carla Viegas. So Carla has asked, were the results of pesticides analysed together with microbes, including AMR? So I guess antimicrobial resistance.
Yes, thank you. That's a very good question. I'm much interested myself. It would have been it is certainly an opportunity, but we did not do that in this study.
Yeah, that's one of the things with research. There is a scope. It's very difficult because there's always lots and lots of different metrics we'd like to look at, but yeah, within Sprint it wasn't in scope. A question from, is it a different Carla again? No, it's Carla Cohen again. So, did the teams find health effects that are potentially related to the findings of pesticides?
Yeah, maybe I should have explained that in Sprint we have not studied health effects. So also not in the let's say homes of the where we collected the dust.
Brilliant. Another question from Carla. So the use of non-approved chemicals is impressive. Is there an explanation for this occurrence? And she mentions it could be considered criminal behavior.
Yeah, so of course we have to, I don't know if you can call it criminal, but I think it was a very, let's say, we were not very wise to start to use very persistent chemicals like the olefluorines, like DDT in the past, because we are still seeing those substances circulating in the environment and also in homes. We have, for example, lindane is also a organic chlorine that is often found as a wood preservative, in wooden floors in old houses, often found. I think in France there was a study done. So actually, most of the chemicals that we find that have been banned are actually still from the past. I would not exclude, let's say, the possibility that people are also, especially in private homes, maybe using chemicals that are not authorized anymore. If you are still using you're still leftovers, let's say, that's still possible. So certainly I would say try to be very critical about buying, new stuff and storing that at home. For many reasons, also for if you have children in homes, that's not a very good idea. But also, let's say, because of I think every 2 months, pesticides are actually the authorization is ended. So there's many, let's say, authorities are much aware of problems with pesticides and uses of pesticides.
Brilliant, perfect. Thank you for the really comprehensive answer. It's very helpful. Another question is around, so I guess how we're sharing our results, and the Sprint Final Conference will be a big opportunity for that. But Carla asks, are we specifically sharing our results with public health services so that we can aim to increase literacy around preventative measures? So I guess some of the no risk measures that you mentioned, Paul.
Yeah, I think for the Netherlands, I have been involved myself, and we are actually from the start collaborating with the regional health services about, let's say, the study protocol. We have had discussions and also communication about our project, and we have also invited our colleagues at the from the government to discuss what type of advice we could give, and also we have checked that our recommendations are much in line with the recommendations that are published online by GGD in the Netherlands.
Brilliant. And a final question, I believe. I don't think I've seen any others. This was a question from our registration form. So participants had the opportunity to ask questions in advance of the webinar. So one of our participants has said, I don't believe Sprint has looked into this, but I wonder whether Paul or Daniel, you know of any research that has. They've said, do you already know of any toxicokinetics assessments on finding out how pesticides might enter the systemic circulation, or any sort of preliminary risk assessments on this?
Yes, actually, we have been working on that, but that work was restricted to 3 priority chemicals: glyphosate, acetamiprid, and tibuconazole, because it's a lot of work. But we have done some studies to construct specific models, PPK models, to be able to do predictions of where these chemicals go. We also use those models for back calculation from our biomonitoring results back to uptake for interpretation of the biomonitoring results.
Yeah,
this is
brilliant.
work that has been done, but it's not completed yet. So we hope to publish the results in the coming years.
Yeah, so the best thing to do there to make sure that you see all of our future results and research is to sign up to the Sprint website mailing list. So if you visit our website, I'll post it in the chat shortly. You can sign up to receive hot off the press publications and research and results. Anything that comes out after Sprint, we will also try to circulate through other channels. Brilliant. Okay, so I think that's all of the questions, unless you have any final questions popping through in the chat. I don't think I can see any. So just to remind everyone to please sign up to our final conference. This is taking place in Brussels at La Tricoterie on the 25th of June, so just in a few weeks' time. We are also hosting this online for anyone who would prefer to join via live stream. So please visit the link that I posted in the chat earlier today, and we'd love to see you there. This will be the first opportunity to hear some of our final key messages from the broader project. Aside from that, thank you all for coming, and please do keep in touch via our mailing list. Contact details are also available on the website should you have any further questions. Brilliant. Thank you so much, everybody. Bye.
Yeah, bye-bye. Thank you, Charlotte, for moderating the session.
Thank you.
Thanks.
Yeah, and thank you, Paul and Daniel, for brilliant talks. Really fascinating stuff.
Okay, bye-bye.
Bye, everyone. Bye.